So let's take a look at this question 154. This is a little bit interesting. So the subsets of the set WXY are WXY, WX, WY, W. Okay, so basically this is all the combinations of what you can get out of this. So if you have, one variable, so the WXY, two variables, WX, and three variables, WXY. So what you're looking at is that the total number of possibilities would just be, okay, so 1, 2, 3, and then that's 3 choose 2, which is just 3 basically, and then 3 choose 3, which is just 1. So what we're doing is we're doing the same thing for W, X, Y, Z, Z. So you're saying W, X, Y, Z. That's obviously the 4. If you have one possibility, you have W, X, W, Y, W, Z, X, Y, X, Z, and Y, Z. You have 6 if you have 2 of them, right? If you have 3 of them, you have W, X, Y, W, X, Z. Then you have obviously W, Y, Z, and then X, Y, Z. So that should actually be, this one is going to be 4C3, so there should just be 4 factorial. I mean, it's basically, what you're looking at is you're choosing 3, so it's 4, 3, 2 over 3, 2, so there should just be 4 of them at the end of the day. So there's 4 of those, and then you have 1 of the WXYZ. So out of all of these, you have 1, 2, 3, 4, and there's 6 of those, so there's 10 there for 15 total, right? Out of WXYZ, and you want the ones that contain W. So there's 1 there, there's 3 there, and there's 3 there. So what you're getting, and then 1 there, so you're getting 8 of them actually. So 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, and 8. So there's 8, so it should just be D as your answer. Now, if we were to take this 155, this is another combinatorics question we can have a look at. So what you're looking at here is, okay, so 5 cars to be displayed in 5 parking spaces. All right, fine. All the cars facing the same direction. Of the cars, okay, so 3 are red. So red, red, red. 1 blue, 1 yellow, like this. Anytime you see something that's listed like this, red, 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 blue, yellow, you're looking at a Mississippi rule. So you take the total. That's 5, because there's 1, 2, 3, 4, 5 spaces, right? So the spaces, and you divide by the repeated terms. So it's 3 factorial for the R's, and then 1 factorial for the B, which you don't need to write, and 1 factorial for the Y, which you don't need to write, because 1 factorial is 1. So basically, it's just simply just going to be this 5, 4, 3, 2 for 5 factorial, and 3, 2 here. So there should just be 20 possibilities, and that's your answer. Other than that, let's see, which other ones do we have? Okay, so we have another combinatorics question here with 152. So we'll move down to that here in a second. Okay. All right, yes, let's look at this. So 1 of 7 candidates for mathematics and 2 of 10 candidates for computer science. Okay, so what we get is mathematics and we have computer science. We're going to keep those separate here. 1 candidate for the mathematics is 1 of 7, so 7 possibilities. 2 of 10 candidates, okay, so fine, there's 10 candidates total, so 10 to 9 here. But the order is not going to matter here because it's just, 2 people. The, person A, person B is going to be the same as person B, person A. So if the order doesn't matter, you just divide by factorial of the group size. So that's 7 times 5 times 9, 7 times 45. Which is just going to be, out of these numbers, is 315. Is the only thing that's even remotely close. But I mean, that does work because 7 times 40 plus 5, right? It's going to be 7 times 40 is 280, right? Plus 35 is 315. So it's definitely 315. And then I think the last one here that's useful to look at on this page is 157. Okay, so 10 books on a shelf. We have 4 paperbacks and 6 hardbacks. Okay, so fine. So we're going to select 5 books, and we want at least 1 paperback, at least 1 hardback. So the at least, with any kind of counting or probability, so at least means total minus what we don't want. Okay, so what you're looking at in this case is it's the total. The total should just be, so it's total minus no hardback minus no paperback. So if we have that, that's at least 1 paperback, at least 1 hardback, right? The total should be 10, select 5, 10, choose 5. The no hardback situation, so we have 6 hardbacks, in which case, okay, that's going to be, we're selecting all of them, right? So the no hardback situation, we have 4 paperbacks. There's actually no way that we can select 5 hardbacks. So it's basically, this is impossible, because what you're going to end up with is 4C5. You can never have this number be smaller than that number. That's actually an impossibility. So that ends up, essentially, this is just 0. And the no paperback situation, well, you have 6 hardbacks from which you're choosing 5 books, right? So the 10C5, so that's going to be 10, 9, 8, 7, 6, and then over 5 factorial, 5, 4, 3, 2, so 3, 2 is 6, 10, and that cancels to 2. So it's 18 times 14, 252. And then the 6C5, that's easy to do. That's going to be basically what you're looking at, 6, 5, 4, 3, 2 over 5 factorial, which is 5, 4, 3, 2, which unsurprisingly is just 6, okay? So 252 minus 6 should be our answer, which is 246. And that's your answer, D.